was a great introduction. This year I've probably heard from 1,000+ people that are interested in the topic and talked to a ton of different enterprise companies. Who here knows what Redis is? Hands? Yep. So a lot of customers. Who here knows that Redis is a vector database? See? So a lot of talking to do. And that is the point, is that I've had to do a lot of talking to educate people on how you can use Redis in these scenarios and help these customers actually build it and put it into production. And not always successfully, to be completely honest with you. But what I'm going to share today is what I've learned from all of that. And this is a previous talk, if you were at large language models in production, the MLOps community one. This is essentially an advanced version of that talk. Since I was asked to be technical, this is going to be a lot of technical information. I promise to get through it so there's some questions, but please enjoy. Okay, so I'm not going to beat this one up because you've probably heard about this a ton today. Large language models are used almost everywhere right now in all types of applications, and they're used for a number of different things, from summarization to question answering and all types, and they're often supplied by external knowledge bases called vector databases. They do this through vector similarity search. And this is something that is together, you can see platforms like Amazon Bedrock being able to string infrastructure together to be able to do this. And so there's a couple things that come along with using large language models that are going to help us ground why RAG exists in the first place. And then we're going to build up into how it's actually used. And then how do you do it? So cost, quality, performance, and security. Cost, because large language models are expensive, especially generative ones that are really good. And quality, because they often make stuff up. If you ask them to do things, they do it. They have no knowledge of right and wrong. They are instruction-based models. You instruct them, they do. And so if you instruct them to do something and they don't know, they will make something up. And so their quality is often bad in certain scenarios that you're not necessarily always thinking about. And it's been a case of many times of those failures that I was talking about in the systems that we had. And a lot of times people call those hallucinations. I don't love that term. Really, it's just wrong information. Because it kind of personifies the LLM to say hallucinations, like it's hallucinating. But really, it's just wrong. It's just not the right answer. Not the right information. Performance, because does anybody know what the QPS of a lot of these large language models is? Queries per second? It's like 2. It's like 2 queries per second. And you know what the queries per second of a single open source Redis instance is? It's in the thousands, let's put it that way. And so you have systems where you suddenly have a large bottleneck. And do you span that LLM out and create copies? Well, what happens to that first point there? Your cost goes way up. And so you have to start thinking about how can I take these attributes and make them work together. And lastly, security. What happens if you want to deploy a RAG system where you have something that is internal and external, right? How are you separating that data? Okay, so this is where I start to say grounding RAG. We're going to rethink the data strategy, okay? First, everybody wants this. It's a private ChatGPT. I've probably built 30 of these this year. It's just ChatGPT plus our internal knowledge base of a bunch of PDFs and notes and whatnot that we have at the company. PowerPoints, you name it. And there's all types of modalities. Everybody wants that. That's the goal. Now, do I fine tune to get this? Do I take all of that data and then create the, let's say, the Redis LLM on all of our internal docs? I could. And it would certainly become better. But usually, fine-tuning is much better for behavioral changes and how it speaks, how it acts, rather than what it knows. And this can also lead to security issues. So that internal-external that I talked about, what happens when you want to use the same LLM? That knowledge is in its parameter set. You can't then ask it to go be an external LLM, because it has that knowledge. If prompted correctly, it will say that information. So do you just feed everything into the context window? Just say, OK, I'm just going to slam all this information in at runtime? Well, first of all, you have the limitation of even in the best model it's 32K. But what happens then when your costs start to go up? And then on top of that, relevance. If you say that this is the context for the question that you're supposed to answer, and then there's irrelevant context, that model is going to use that context that's irrelevant to answer the question. You're instructing it to do so. And so there's a middle ground. And this is where we're going to talk about vector databases. And this is kind of how I talk about this, because a lot of times it's not either or. You do one, and then maybe you do another. You fine-tune a model to change how it acts or how it talks, and then you also have an external knowledge base in the form of a vector database. What do vector databases do? They perform vector search, vector similarity search if you want to expand it out. This is an oversimplified vector space that you see here. It's obviously not two-dimensional. These vectors are of 1536 dimensions in the case of OpenAI, and they're often, there's a lot of times they're even bigger than that, honestly, if you go on Hugging Face. But what you see here is a semantic search space of 3 sentences. It's today's a sunny day, that is a very happy person, that is a very happy dog. And then you have a query, okay? And that query is that is a happy person. And what you want to calculate is how far is that sentence in its semantic representation from the other sentences in my search space. And you do this by having those vectors and doing the same thing you did in 5th grade when they taught you SOHCAHTOA, which is cosine. Cosine similarity between the 2 angles in that search space. And so then you get a distance, a vector distance. This sentence is this vector distance away from this sentence. And I always do this. Because really that is all you're doing. And that is an extremely efficient computation. That's why these things can have billions of vectors, and they can perform billion-scale vector similarity search because they're doing a very, very simple mathematical operation. And in this case, it's only 3 vectors, but you can scale these into the millions, hundreds of millions, billions. And that's because these representations are very computationally efficient. Think about taking an extremely large paragraph and boiling that down into a vector with 1536 floating point 32 numbers. You're going from megabytes to kilobytes. And so that representation is more compact, space efficient, and in runtime, more computationally efficient. And on top of that, it's better than things like BM25 because it accounts for things like synonyms. If you say brother and you say relative, a BM25 is not going to count those 2 words as the same. But a semantic search that has the knowledge of a model that's read all of Wikipedia and all of Reddit encoded into that semantic vector will know that relative and brother belong to the same category, at least relatively, pun intended, of words. Now, what do vector databases do? They essentially just put this operation into production. And I won't spend a lot of time on this because I got a lot to get through. So the one thing you should know here, as I mentioned earlier in the talk, Redis is a great vector database. I won't talk a ton about why Redis is a great vector database today, but if you want to know, come talk to me afterwards. So what is retrieval augmented generation? How do I use a vector database as a knowledge base? Well, I always love this one because a lot of people are like, oh, vector databases, everybody wants them. The market's so flooded. And the truth is that this is why. Is that you have people like Sequoia putting out stats that they believe 88% of these large language model applications are going to use a retrieval mechanism, whether it's a vector database or not. And so in this case, you can see they're saying it's doing those things that I talked about, that middle ground between those 2 operations where people do use large language models. And so that middle ground is filled by retrieval in this case. So what is the process? This is really simple, definitely oversimplified diagram. But you have a user query. Let's say, what is Redis? That goes to an embedding model. That embedding model then gives you a list of numbers. And it's just simple floating point 32, B float 16 if you're doing an optimized or a quantized approach. And then you have a vector search, which using that embedding returns passages of text. In this case, I'm saying documents. Just imagine it returns you a bunch of PDFs that are relevant to the user query. And then you create a prompt. It says, here's a question. Here's the context. Now answer that question. And that's all RAG is. That's the entire concept. It's saying, I have, and it doesn't necessarily have to be Q&A, by the way, and I'll show you that later. But in that case, all I'm saying is I need more information than present in the large language model to do something, whether it's summarization, question answering, what have you. You might use something like Cohere or Hugging Face to use the embedding model. Obviously, you'd use Redis as your vector database. And you might use something like OpenAI because their generative models are currently really good if you look at benchmarks. And then to chain this all together, You might use something like LangChain, or if you really want a high-level GUI, you might use Relevance, or Llama Index with Jerry Liu's company. So the principle here, and it's really simple, more relevancy, more relevant context, you get a better answer. And that's one of the most important things about it. There's a thing called a range query, which does, if you were looking at that space, that diagram earlier, you can specify a vector distance, a range away from it, such that if you don't get any context, if it's not within that range, if it's not similar enough, then you can say, don't say anything, you don't know anything. If you want that model to be strictly bounded to that search space, then no hallucinations. Because it's only ever going to generate something with that context if it gets retrieved. And that's relying on the retrieval. You're then flipping the problem around and saying, I'm relying completely on my retrieval process in order to generate this information, which leads you to just have to curate the retrieval process. And then you can rely on other people for the LLM sometimes. The benefits of this are it's cheaper and faster than fine-tuning. It's better security, like we mentioned with fine-tuning earlier. In a case of databases like Redis or even some other vector databases, you can update this in real time. Imagine if you had a network of sensor data and you were an incident engineer and something happened and you said, what just happened to machine 4? That data has to be new. You can't re-fine tune on that. You can't stuff all of that information into the context window. It has to be in a real-time data platform ready to go. And then lastly, like I was mentioning, it allows you to have multi-tenancy. It allows you to separate these users from those users, that company from this company, and those documents from those documents. And that is a really important part of actually having knowledge in these systems. So, as I mentioned, it's used for more than just question and answering, although currently a lot of them seem like question answering. But there's more than just that in the system right now. OK. Summarization is also really important. If you have we have an archive demo that I'll show later, and you can take a bunch of archive papers and say, hey, I don't really understand this, summarize it in English. That's essentially what it does. And then you have the customer service applications that say, users, oh, hey, what was the last thing I ordered? I forgot what it was called. And then you use a feature store to inject their last order right into the prompt so that a customer service bot can tell your users exactly the last thing they ordered and do so in a reasonable amount of time, and they never have to call an operator again. You never have to sit there and go agent, 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 ever again. I mean, that's significantly better in terms of user experience. And these are the types of things that people get really excited about, is the change of user experience from one methodology to a whole completely new way of doing it. OK, so taking a step back, what really matters here? How do I take these systems to prod? You roughly understand the process now. I want to talk about two abstraction levels. First, a service level, OK? And this is the service around the RAG system. Everybody wants to talk about the one on the right, the very kind of, in my mind, somewhat simpler system because of the results. It's really flashy. It's cool. These LLMs produce great content, and it's interesting. Yet, these systems are still hard to put into prod. You still have to do things like caching and monitoring. And we're going to talk a little bit about how it's more like this. The service encompasses the RAG system, and it may even be like this, where you may have multiple RAG applications deployed on the same infrastructure. And we'll show examples of how to reduce the complexities there. So first, we're going to talk, though, about the RAG level system. This is an example of Q&A system. And this is also on the Redis Ventures GitHub, which you can go check out. But there are essentially two processes here that you have to accomplish. And this is an oversimplification again, but I'm going to get more complicated as I go. First, you have a background process. The background process is I take some number of documents. Let's assume that I take the entire corpus of the document for now. I use an embedding model to create a vector, and then I put that into my vector database and associate that vector with some text that it was used to create it. And then there is the online system. The online system is where a user enters that query. That query then gets embedded just like you did before. That embedding is used to look up information, text, in the vector database by performing vector search and returning the associated text. And then you send that in a newly constructed prompt to something like OpenAI to perform a generation. This, again, is an oversimplified process, but this is really the kind of high level of the RAG level system. Now, let's talk about some specifics. OK, I just said we take the entire corpus of the document. You almost never do that. Almost never. And the reason is because of what I was talking about earlier. It's hard to search semantically over an entire PDF. There are different meanings in an entire corpus of words. And so if you have a user query, even if you're using like an approach I'll show later, that query doesn't look like almost anything in that document. And especially at the size of that document, even if you're taking that entire document. So in this case, the simple approach would be just take that raw text and use it for the embeddings. And then have that system we described before. It looks something like this, okay? Now, the problem with the approach, as I mentioned, is the unrelated context surrounding the text that you actually care about. And that makes the retrieval, and I said, in most of these RAG systems, you're actually relying on retrieval. And so the retrieval is actually the most important part if you're using a vector database like this. And so that filler text actually really degrades the search in terms of even recall, like very measurable statistics. And so instead, we want to do some other things. This one's courtesy of Jerry Liu at Llama Index, great guy. Instead, you could take that entire PDF and create a document summary. Think about like an abstract of a paper. That is much more concise. The semantics of that information are much broader. They're much richer. They're much closer to what a user query may be. Even if you do have specifics, you can then use the summaries as the high-level retriever and then do another semantic search through the chunks retrieved from that summary. So these are actually two separate vector searches that are going to happen. First, you use the summaries and do a vector search across the summaries. And then you return the document chunks and do either local or in database, if you can do chained operations, in database vector search to retrieve between those chunks. So in the paper example, we use abstracts. And then we go through the entire paper. Imagine like, do you want to talk to this paper when you're on archive.com? But instead of a BM25 text bar at the top right, it's semantic search through the abstracts and titles. And then you can click on the paper and say, hey, I've got a question about this. And what it's going to do is only semantic search through that paper. And there's a great feature in Redis called temporary indices to do that, by the way. Anyway, next, you can also spend a bunch of money on embeddings. So this approach, you take something smaller, something like every sentence, and then you take all of the context around it as what you return instead. So you're only ever doing semantic search on that specific sentence, right? And so that query is much more likely to be similar to one specific sentence, which does improve the retrieval. But then for the actual context retrieved for the LLM, you return much more surrounding text. And so you can do this through things like overlap, but essentially this is used in cases where more context is often needed. So things where more information is going to be better. As I mentioned earlier, that's not always the case. And so going through these data preparation strategies and going through your problem, what is my user query going to look like? What is the end-up system going to look like in terms of the retrieval? How do I test and evaluate that retrieval? And all of those steps matter for data preparation because it basically all starts there. And your quality is going to largely depend on data preparation, which is why it's my first slide. And this is the archive RAG demo that I was talking about. It's right now, the deployed one is just semantic search. And you can use OpenAI and Hugging Face because we have two indices up there. But if you want to look at the RAG one, it's on Redis Ventures. OK, so that would just be semantic search through the abstracts if you want to go check it out. It's hosted. It's a small EC2 server, though, so it'd be nice. Hybrid querying, probably the most important feature of vector databases. And it's ironic because it's the feature that doesn't actually use vector search. And so this example here, let's say I have two sets of documents written by Paul Graham and documents written by David Sachs. And then in those documents, I have pieces of text from those documents. And the problem is what if I only want information from, what did I say, David Sachs's documents, or Paul Graham, whoops. What if I only had articles written by Paul Graham? Semantic search isn't going to be good at that. What if in a lot of those passages of David Sachs, Paul Graham is mentioned, right? Then you have a problem. So hybrid search allows you to do things like use BM25, like keyword frequency, which I just spent a long time saying wasn't good in terms of vector search. You can use them together. And so you can actually do, it's like a pre-filter. You can say, I actually only want documents written by Paul Graham, and now do my vector search. And at least in Redis, you can also swap that operation. And so this allows you to say, oh, let me get this subset of users, or I want that user's documents, or that user's conversations, or that customer's orders, or that, and it allows you to do this with text, tag fields, BM25, geographic regions and radiuses or polygons. Those kinds of features are really important when you're someone who, I don't know, delivers food, and you have a radius around your store that says, oh, should I search through these specific products in this particular store? And that's what hybrid search allows you to do. So let's give you an example of this. This is the RAG one. So we're using LangChain here, thanks Harrison, and we're just going to pull papers from archive. This actually just uses BM25, okay? So this is very simple, just BM25. And it's going to use the archive loader, and it's going to say, load me 20 documents about retrieval augmented generation. Just going to check my time. Okay. And those are going to get raw documents back. So these are PDFs parsed with like PyPDF or PyId PDF or something like that. And then we're going to index them into Redis doing this with OpenAI embeddings. Now, usually you don't actually have to use OpenAI embeddings. There's a lot of other embedding providers, but it's the most recognizable, so I use it at talks. So then it's really easy, actually, using LangChain. This all loads up all the documents and all the metadata, and I just recently implemented automatic metadata generation. So in this case, if you use the archive loader of LangChain, every time it's going to load, you see load all metadata true, it's going to load all of these categories. So then, see if the laser pointer works, all of these fields I can then do hybrid search on. So now in my RAG, I can say, oh, well, we'll get to Redis VL. In my RAG, I can say filter by the category and year. Okay? And so now I can say I only want machine learning papers, CSLG, and I only want them to be published in something that starts with 2020 something, so anything in 2020s and beyond, right? And then I realize I said 2023 there. It's anything in 2020. It's a fuzzy text search. But then you can combine those by saying and that's really cool. So this is all new features of LangChain, and so you can combine those two filters together using Boolean operators, and you can do this arbitrarily long. And so you can have SQL-like expressions now in your RAG system to do a hybrid search, which is super cool. And then you get your results. And so here it's going to be doing relevancy scores, which is going to be 1 minus the cosine distance in this case. And so that would be the score. And so this is how similar those documents were to my query. And so you can see retrieval augmented generation is the top paper. And I'll go back and show you that that is the query that we wrote. And now you might say, that seems similar to something that BM25 would do, right? But in this case, we're able to do this across all different types of documents, and we're able to say that you only want a specific range of semantic similarity included. And so I'm only ever going to be returning documents that have a certain level of semantic similarity to that specific query, and then hence enhancing my retrieval system and hence my LLM application. So also, this is Redis VL. It's a command line tool to look at your Redis and the library to look at your Redis schema is what I'm doing right there. It's really cool. It's purpose built. I don't know who built it, but he's probably really cool. And next, hybrid queries in LangChain. Just talked about this a little bit, but you can see a bunch of examples there. I'm going to make sure I get to the rest of this, so I'm actually going to skip over this a little bit. Okay, next approach, hide. One of the more fun ones, okay? Using fake answers to look up context. So like, let's think of a Q&A system here. I'm going to have a user's question, and then I'm going to use an LLM at first to generate a fake answer. Now, why would I do that? A fake answer is often more semantically similar to a real answer than a query. Think about it. Like, what is Redis? And an LLM-generated answer to what is Redis, something like an in-memory database that can be an awesome vector database, is the second part of that. That answer is more semantically similar to what I'm looking for in terms of context than what is Redis as a query. And so if I'm using that to create an embedding and do my vector search, then oftentimes it's not as good as if I actually have an LLM purposefully hallucinate an answer and then create an embedding from that hallucinated answer and search with that. And it's a really cool technique. It doesn't always work, and it's for specific situations, but it can be really impactful to retrieval. And this is actually, I think Jerry and Harrison have both, Llama Index and LangChain have both implemented this now. And so you can use this like hide approach that will do it for you automatically. Now, this is really slow. It pings an LLM twice. So you got to be able to have like a 30-second response time. And I can show you an app about this, but you should have it as often a backup plan for when something like no context retrieved. So you do a vector search, right, which is often really fast. Cheap embedding model, vector search, I didn't get anything. What do? In the background, you can be doing an asynchronous call to a hide service that is running that. And so while you kick them off at the same time, and then in the background, if you don't retrieve any context, you can return that hide answer. And then that's a really efficient way to say, and that's how we speed up a lot of the hide ones, is that it's like your backup plan in case none of the context gets retrieved. And so you run concurrently, like an async IO gather or something like that. OK, I'm going to show you an example of a hide one that's really funny. I built this for fun. This had no practical commercial application, but it really shows off the hide approach pretty well. So this is online. You can get it on the Redis Ventures GitHub, so I'm not going to show a lot of this, but you see the separation of offline and online that I was talking about here? So the bottom part, there's a line. Bottom part is offline. Top part's online. Offline, we're creating embeddings. And sometimes that is online, too, that you have to do constant updating, but I like to separate those two. Online, in this case, we have a Streamlit GUI, we have a generative model, an embedding model, and then we have a fast API backend in Redis. And that's it. And those things allow us to create a process that uses hide to generate a recommendation for a hotel. Now, how does it do this? It's going to take user inputs, positive and negative qualities of a hotel. So I'm going to say something like nice amenities, like a pool and a gym. And what do you want to avoid in a hotel? Mean staff, OK? And then it's asked to generate a fake review embodying the positive and opposite of the negative qualities, OK? So think about that again. You ask an LLM to say, write me a review, which will likely be way more similar to the reviews in your data set, semantically, and embodying the positive qualities and the opposite of the negative qualities. And so in this case, to touch on the point about prompt engineering, you know what the most impactful thing about this retrieval was? It increased the context retrieval by like 7% on the evaluation set. In the prompt for the LLM, including you're not that smart, because it would often write really well-written long reviews instead of the ones that were in the data set, which were generated by us. So saying you're not that smart actually made it semantically more similar to the reviews in the data set, which is a hilarious point about this whole demo. It's still in the code base, so you can go check it out. So once it does that, you're going to do a semantic search, and you're going to generate a recommendation with another prompt, okay, that says, given all this context and given the user's positive and negative qualities, what does the user want? Recommend a hotel. And in this case, it says, the Alexandrian Autograph Collection is a great fit for you because it offers nice amenities like a pool and a gym. As mentioned in the reviews, guests have highlighted the hotel's convenient location near public transportation and the waterfront, making it easy to explore the area. The staff at this hotel is highly praised for being amazing, friendly, and helpful, ensuring a pleasant stay, which is almost exactly what the user wanted in this case. And it's actually really good at recommending hotels. And what you see on the left actually is state and city. Those are hybrid filters. So if you actually kind of want to use this to go look for a hotel, you could. And personally, I built this because I was frustrated with a certain, they're a customer, so I'm not going to call them out. But I was frustrated with a certain travel platform. And I thought, why can't I just talk to an LLM and have it read all the reviews for me and generate me what I want? And this does roughly that. I mean, there's some sharp edges, but you get the point. OK, and then you can see that it not only does that, it generates it, and then it returns the reviews it generated it for, right? Because when you retrieve context, you can just save it in a state variable in your front end and show it to the user. And they refresh it, and you search again. And so in this case, you can also store metadata, like the hotel name, the state, the city, where its address is. So you can even get further, give them directions. You can have them where they are geolocated and give them directions right to the hotel. And so you can build whole new experiences with this kind of thing, and that's what people get really excited about. And that's what we've seen a lot of companies do and make some really cool applications with that hopefully are coming out soon. So that was a lot about the RAG level system. So the things you do to actually make the particulars of a RAG application work. But there's a lot more on top of that that can enhance a RAG system that I've seen this year or that I've done this year that I'm going to share with you. So first, this is the diagram we're going to talk about. You do not need to understand this entire thing yet, but you should notice the RAG level system in the top right. Okay? So that's what we just talked about. And that should look roughly familiar with the addition of a feature store, which we'll talk about. However, this is roughly, it's obviously abstracted, but this is roughly what the pieces that we're going to talk about today and how you'd use them in a service around a RAG system. Okay? So, Matt, remember this one for the hybrid search? How do you update your vector embeddings? When do you update your vector embeddings? Okay? How do you deal with duplicates? What if you have the same documents in your blob store twice? What if when you go to re-upload that data, you then say, oh, I just re-uploaded the same document twice? Or you get new data that's incredibly similar, but it's a couple words off, so it doesn't hash correctly or something. There's a lot of problems with actually just maintaining a data set of text. Text is unstructured data. And so maintaining blobs of text can actually be relatively difficult. And so coming up with a system for actually taking all of those PDFs and systematically updating them when a new one gets updated, or say it's a chat experience and every time the customer chats, how does that get indexed? When does it get indexed? And what we've seen most popular, or what we've done, I should say, most of the time are three things. Document level records, context level records, and just pure hot swapping the index. So I'll tell you about each at three of these. So document level records. Something like this, last modified. So you can see the addition. That is not incredibly clear. I should have probably put some boundaries around it. You see last modified right here, okay? So that you can then use in a separate data structure to say, has this document been updated? Because most things like, even a make file has this. You can say, when was the last time this document was updated? And so you can go to your blob store and retrieve that metadata and then compare that to the document metadata in your vector store. And so then you can say, okay, at least I know that this document is now new in my blob store. And that operation is relatively cheap. Now at billions of scale, you need to think a little bit differently, but we've had this up in the hundreds of millions. So context level records. So this will definitely not work in the hundreds of millions because what happens? All of those documents, especially if we're using some of the approaches that I talked about earlier for actually creating embeddings, will create hundreds and hundreds and hundreds of embeddings each. So if you have 1 million in documents, you might have 100 million embeddings, right? And so in this case, if you were to use context level records, as in has this context within this document changed, then you might be incurring a lot of penalties on performance. However, if you have a system like an FAQ, we have one of these, that has very strict boundaries, and it's relatively small, but there's still, say, 400 something questions and answers, right? You can say, has this answer, has this piece of context, has this paragraph within this FAQ changed? And that is when it's actually acceptable to just change the context. You don't need to change the whole FAQ every single time, because that'd be still creating, 10,000 plus embeddings every so often. And you're incurring a cost that you don't have to. And so lastly, there's hot swap. This works better for platforms that you actually just rebuild the index every time. But in this case, because Redis does asynchronous indexing in the background, but hot swapping is where you just say, it's like an A/B test. You say, I'm just going to build an entirely new index and then alias it to the first index. Now, this is obviously the most expensive route, but it's often one that people do when they mess up. I've done it myself. And so knowing how to do this with your platform is actually really important. And so that's why it's in here. OK, non-vector data storage. We talked a little bit about metadata, but where do you actually put it? Do you put it in a SQL server? Well, we talked about that LLM already has a QPS of 2. So your system's really not going to be very fast. If you have to go to a vector database, do a vector search that gets a pointer over to a SQL store that then calls an LLM that then goes back to the SQL store to retrieve some other pointer, your system's going to be slow. And so the advice here is don't separate metadata from vectors. When you do your vector search, retrieve that metadata. And so I did this for NVIDIA in a recommendation system. There's a GTC talk about it, so you should definitely watch that. And you see the box there that says 161%. That was the increase that we had in inferences per second of this recommendation system by taking metadata that wasn't co-located and co-locating them in JSON documents within Redis. And so in one vector search, instead of 2 network calls like on the before side there, we could return all of that necessary metadata. And not doing that network hop and profiling our network correctly, we were able to get 161% improvement in inferences per second. And there's a lot more to that talk. I go through 5 optimizations, as you can see there. So if you want to go, if you're in recommendation systems, that's a good one. OK, feature injection. This is another really interesting one. Talked about this a little bit earlier, so I'll skip over it mostly. But you can see the prompt there. If you want to have a chatbot experience, you can maybe include the chat history there too. But it's really important that you also have things that may be rapidly updating. Okay, so the user's address. Okay, the user may have changed that address, and now that might not be rapidly updating, but that might actually get updated in your platform. So you don't necessarily want to be pulling that information from a slow storage system if it's a chat experience. No user's going to wait for your chat experience to last 30 seconds. That's got to be under 5-second responses almost every time to increase retention. And so in this case, you can have a feature store, an online feature store specifically, or a fast feature store, let's just put it that way, that would be used to pull that information into the prompt. And you can use agents. There's stuff like in LangChain and whatnot that you can hook up to your feature orchestration platform, whether you're using Tecton or Feast or what have you, and you can pull that right into the prompt so that your chatbot experience can now be enabled to know things about your users. And so you can imagine this doesn't have to just be users, too. I gave the systems example earlier about sensor data and incident engineers talking to sensor networks. In that case, then, too, the sensor data is fresh every 15 milliseconds. And they can ask their questions, what's going on here? Make me a plot of X. And it's going to plot out that sensor data. And that's how, because these models are often, you can make it multimodal now, that is how feature injection works. OK, semantic caching. This is a really good one. Let me just do a quick time check. OK, I got to hurry. Vector database used as a cache. Now, why would you do this? So let's say, actually, I'm just going to go straight to the example, actually. OK, let's say we said the query in a Q&A system, what is the meaning of life? OK, now this is kind of silly. It responded with something awesome. I don't remember what it was, actually, but I remember it being great. And then what if another user somewhere else in the world said, what really is the meaning of life? Do you think that LLM should recompute that answer? No. Why are you spending an extra 0.02 cents on that query embedding and then money on the generation too? No. You should have it so that if it's semantically similar enough, you just return a cached answer. And so this is how semantic we gave the FAQ answer earlier. We have a couple use cases where people just completely pre-populate. And so that the LLM almost never gets invoked. But it does in a couple cases. So it's super bounded. And it also allows you to basically predefine a lot of answers. You're essentially using your evaluation set as the system. And now this is when your evaluation sets are very large. That can be useful. But in this case, you're not only saving on money, but your QPS goes way up on average. And so in this case, it was, what, similarities 0.97, right? And it was a 97% speed up. Actually, that's kind of ironic. But in this case, we're saving that much time and decreasing the latency by that much. And so this is also Redis VL, which hopefully I pop up. I didn't. OK, this is also on Redis Ventures GitHub. This is the client. It has a built-in abstraction that you can see here for semantic caching. You can just say set threshold and change that threshold There's some hard parts about this, like where do I set that threshold based on my application? I don't really have time to get into that, but it's also a fascinating topic, so if you have questions about that, come ask me after. Okay, so now, what do we know about service level systems? Well, we talked about updating embeddings and when and where and how to do that, right? And so that data pipeline matters. Now, obviously oversimplified in this image, but that really matters in thinking through that before you go into prod with these types of systems. We talked about using a feature orchestration platform and including that into your prompt by using things like a vector database, a feature store, and a RAG API, something like LangChain or Llama Index, what have you. And then we also talked about semantic caching and how to make these systems significantly better. Now, a couple of things we didn't talk about that should be in this slide, but I only had a certain amount of time. Reinforcement learning through human feedback. Was that answer good or was that answer bad? Did it give a thumbs up? How do I incorporate that into the platform? Hopefully I can give a part 2 at this at some point. I also didn't talk about external data sources, but I already had a lot of slides, so I was going to cut that down. And if you're looking for more info, examples right here. And so you just take a picture of this, by the way, and then touch the squares later. I made sure that worked. The examples, Redis Ventures has, it's the applied AI team at Redis. We have a ton of just like little applications that we built that can show you how to do it. Redis VL is the client that I showed in like 6 different things. It also built the hotel application with that. And then I tweet about this a lot, and I don't really tweet about anything else. So you can follow me on Twitter, and I promise I won't bother you. And then other than that, we usually post the slides, but I'm not sure if we are for this one, but you can always check on partee.io, which is my site where I post slides from talks. Okay, and then I should be good. I left enough time for questions, right?
Yeah, you do. Awesome.
Sweet. Thanks.
Thank you very much.
Hi.
Hey.
Great talk.
Thank you.
Yeah, what do you think about the, I mean, I think that at this state of the art, we are doing many things by hand, several, like the orchestration level, several things you are doing with the LangChain or Llama Index or whatever.
Yeah.
And it seems that maybe this, what do you think of on these things moving to the vector database, for example? Because in some way, it's like we are creating the index from the relational databases,
Yeah.
so because the documents, the query stuff, etc. All these things are very take times to what do you think that should be the?
You touched on some really interesting points. So first, you wouldn't believe how many company diagrams were like, this is our architecture, and there's a DIY box right in the middle for orchestration. And we're like, oh, so are you just doing it yourself? And then a lot of companies, they assume that they can make those types of systems work as well as something like a LangChain or Llama Index. And even though there's a lot of movement, let's say, on those repositories, a lot of releases are coming out, there's still a lot of great information baked into that code. And so what I see a lot of people doing, they might go do a LangChain example as a POC. So I've seen some take some to prod, even enterprise companies, but I see a lot of people also using a lower level vector database client and building up those kinds of abstractions by building a POC in those and then kind of extracting the process over to a lower level client. That's also why we're trying to build Redis VL. But that's a great point, and it's something that I see a ton. It's important that also you don't lose that kind of information from LangChain, but your point on the vector databases is good. If you look at like what Bob at Weaviate's doing with like the generative search module, that's actually really, it's very similar to what you just said, is like trying to take a lot of those abstractions down to the vector database level. I think it may be something in the future where if that generative search process changes, that it'll be an overextension maybe, but I mean, who can predict the future, And so that's what I mean, is that it makes it super easy to get started though, and I know that for a fact because I have a lot of people, especially customers, that have said like, oh, so where's your generative search module? And we're like, you do it. So yeah, I totally understand that, but we're yet to see how far it's going to extend down to the infra level. I think a lot of people that are at the infra side of things kind of want to focus on search algorithms, HNSW, what have you, and then leave the rest of the stuff to LangChain and OpenAI. But we'll see. Great question, though. Great question. I could talk about that for a while. Oh, yeah. Hey.
Hi, again, great talk.
Thank you.
So you spoke a lot today about sort of using vector databases to feed in contextual information into the LLM. Of course, recently we've seen the surgence of like agent architectures.
Yep.
I was wondering if you'd seen any architectures in the wild where that dependency was inverted, right? And you have the LLM decide to reach out into the vector database and search for what it's looking for, rather than you pre-populating it. So it's like
Interesting. Yeah, tools. Yeah, so the router, I think it's called, in Llama Index is a really interesting example of this, where like you can have a bunch of predefined tools. I think that's what it's called. If I'm getting the model name wrong, don't burn me on that. But it's cool because you can give it a semantic description. And so when a user has like a problem or they ask for something, right, they can search for the tool they need to use. Let's say it's a browsing tool or a vector database tool or what have you, through semantic search. So they can semantically search for the tool that they need in their gigantic list of possible tools. And we have seen this. However, I haven't seen a lot of them in production because it's, let's say, fragile in some ways. Like if you allow it to browse the web, you lose that contextual bounding box that I've been talking about a ton today. And so these agents often just, or even tools, can really go and do some interesting things. And so, you know, when you take things to prod, hence the part of the talk today, it was really focused on like trying, at least in the current moment. And that may change in the future when these agents get better infrastructure around them. You know, we're still wooden horses on dirt roads in this field right now, in my opinion. But it's still really important to put a bounding box around them, especially when you go talk to enterprise companies, because they really don't want to see this LLM say the wrong thing, especially if it's a customer-facing one. Internal use cases, a little bit more leeway. You could probably see an agent get used in those. But right now, that's kind of the state as I see.
Thank you.
Yeah, absolutely. Yeah.
Sometimes recency is pretty important, especially for...
Sorry, what did you say?
Recency.
Yeah.
So how would you include something like freshness?
Yeah, so great question. So you could do numerical as a hybrid search, right? So you could do a numeric, like a recency score that gets updated, right? And so every time the vector database gets updated, you update that recency score. And it doesn't have to be like a last modified tag, but it could be a score that you create with a separate service. You know, you could have another ranker or another system that's creating this recency score and storing that value such that while you have another system, which is a good kind of separation of abstraction, you can have another system then utilizing that recency score. I would say I don't know if numeric would be the best way to do it, because then you're kind of bounding it by range. You could do sort on demand by it. A lot of vector databases support that, but then you're losing the vector distance. If you did a vector range query and then you did sort on freshness, that would actually be another way to achieve that. I'm not sure off the top of my head of any others, but it's a good question. And recency does matter a lot, especially for like a news application that we did. So I totally get that, and that's a great question. Yeah.
Hey, really appreciate the talk.
Yeah, thanks.
I think when I was thinking about approaching these kinds of problems, I had sort of naively assumed that I would maybe have the LLM generate a query against some underlying data store. And I think especially thinking about like a more structured data store, like a SQL store, and then have the LLM process the results of that SQL query. Is that something that you've seen people do, or are there problems with it that I'm missing?
Yeah, so that actually gets to what he was saying. That could be a tool. So like I've seen that used as a tool where you might do something and then that triggers, oh, this is information that could be in my SQL database. And then that tool, its job is to do what you're saying. So once it's semantically found that it needs to use that tool, then the query gets generated, query gets executed, and then the results of that query are processed like you're saying. But a lot of times that's actually like to feed into like a graph or like a plot for like a dashboard or something. Like, so it's a chain set of tools. I don't see a ton that are just that. It's usually for another purpose. Hopefully that answers your question. Yeah.
All right, that's awesome. We have time, so thank you, everybody. Let's give hands to Sam.
Thank you.